was one like this. So maybe figure out how to do it. Maybe someone can share when you tell me what the insight is that kind of gets us all the way home on this. There's one kind of key insight to unlock this, and you probably, like I said, if you diligently looked at your homework problems, there's one, at least one like this. So maybe you've already thought it through. What's the move to make sure?
Sine squared of, I don't know what that is.
Yeah, what Greek letter is that? It's actually a, phi or phi. Yeah, keep going.
So like, is 1 minus cosine squared.
Yeah, that's like kind of the big move here, the key to this problem. And then once you have it in this form, now it's just quadratic and cosine, so no big deal, right? We can solve it now. So that was and like I said, I think that, right? Am I right? There was one like that in the whole class, maybe two. So, I mean, we did one at the end of yesterday that looked like this. Well, now it's basically that same kind of problem, isn't it? That was the one we did yesterday. So now that we've had it in the new Shivani form, it's like basically the same thing. Right? So work it out, combine like terms, reduce the factorization, etc. Yeah, fun fact, the null set is not a Greek letter. Did you know that? It's like the only letter from this alphabet, this world language alphabet, that I think we use. You'll never guess what alphabet it's from. What language? It's Norwegian. Okay. Yeah. Is that what that is? No. The book. Oh, I think I should be able to get this one. You couldn't put it down. How's it going out there? Does it factor nicely? Hopefully. Let's see. So how's it going? Did you get to where I'm right now? So phi equals, I feel like we've done this one before, 2 pi over 3 or 4 pi over 3, right? Or cosine is 1. When does that happen? When phi is 0, or how about just 0, right? On this interval, this half-open interval, I think 0 works, and that's it. Okay. So we have only 3 solutions on this open, half-open interval. There they are. Okay. Questions about that process? 2 pi is a solution, but just it's not on this interval technically, just because you know.
Oh.
Sorry, is that good for people? Probably not news to you if you did do the homework last night. I was thinking like if we'd done one like this in class, we could have helped you out on homework. But oh, it's all good. Yeah.
Can you do like
5 pi over 3 has a cosine of positive a half. 5 pi over 3 is in the fourth quadrant. Positive a half. Yeah, and we're only solving on this interval, so those are the 3 and only 3 solutions. All right, here's an interesting problem, which looks simple, but it has some interesting snags for us available. We're always looking for snags, right? We like that. I'll do the first step for you. There you go. And just keep in mind, like, how would you solve, this equation? And I think you would say, actually, we've done this one before, right? Oh, sorry, it's cosine sine. Sine. I didn't mean to do that, sorry. When is sine 1/2 pi over 6, 5 pi over 6, and an infinite number of other things coterminal to those things. All right, so just keeping that in mind, let's solve this problem. So what's the takeaway for us in this problem? What's 2 omega minus 1 equal? That is apparently pi over 6, and apparently could also equal 5 pi over 6. If omega is a number that satisfies either of those equations, it looks like we have our equation solved. Or, like we said, this does say for all omega, so like technically we also need like a plus 2 pi n there, and it's important that we introduce that right now for reasons you'll see in a second. So I'm writing it out separately like that, and I think you'll like that. Now we have still the task before us to solve for omega. So we have two equations to solve for omega. I think you'll agree that we both do provide for us solutions. And so this is like this is that snag. It's like dealing with this end situation here. But it's not. It's okay. We just solve these for omega. Just do it carefully. And notice that we're gonna. So I just added 1 to both sides. Now I'm gonna divide by 2, and notice that everything gets divided by 2, right? Just because that's how math works. Okay. Including that 2 pi n, right? And similar algebra over here. So omega, 12 equals any of the things in these lists where n is an integer. And I have a couple small comments to make about that. So just to be clear, we have this kind of crazy solution, pi over 12 plus 1/2, right? But then, so that's kind of like the one solution we have is pi over 12 plus 1/2. And then it says it repeats this is basically saying, and then it repeats every pi after that, kind of, right? After pi over 12 plus 1/2. And similar with the other solution, 5 pi over 12 plus 1/2 is another solution, and it repeats every pi, we get another one, too. Why is that happening? Why is that we're getting like solutions? It seems like we're getting solutions like twice as often. Yeah. Yeah, if we're thinking in terms of last unit, we kind of know what that 2 does to this equation. It makes this like a horizontal shrink by a factor of 2 or a half. We can talk about the period being half as big. We can talk about the frequency being twice as big, right? Whatever. But it is expected that not just the solutions to this equation, but just the outputs of this expression. If you were to graph it, all the outputs would be repeating. All the outputs would be repeating every pi unit, wouldn't they? Including things that satisfy this equation. One other small comment to make is this. If I were to this actually makes this a more challenging problem on this particular modification. If I were to say solve on the interval 0 to 2 pi, that's actually a little bit of a hard question to answer on this one. I'd actually rather leave it this way. Because figuring out what n values will put us on the interval 0 to 2 pi is actually a little bit of a headache, right? Because I'm thinking there'll probably be 4 values that will be in the range 0 to 2 pi, right? If you let n be 0 for both of these, you definitely get solutions that are on the interval 0 to 2 pi. If you let n equal 1 in both of these expressions, I think you get another solution for both of these that's on the interval 0 to 2 pi. I'm not sure. I'm going to have to think hard about that. Yeah, so that actually makes it trickier.
Can you not just do the plus 2 pi n if you're solving for over 0 to 2 pi? And you get like 2 omega minus 1?
Say it again. So what here?
Yeah. Like
So,
if you're solving from 0 to 2 pi, can you not just do like 2 omega minus 1 equals pi over 6?
no, because there will be other answers. I mean, can you just, for me right now on your calculator, can you type in pi over 12 plus 1/2 plus pi plus 1 pi? and tell me if that's a number between 0 and 6.28. Kind of feeling like it is. Did you hear what I asked? Pi over 12 plus 1/2 plus 1 pi. What is it?
It's 3.9.
So it's like an angle like right about, wait, 3 point what?
3.9.
3.9, so it's like just a little past pi, right? And so that is an angle between 0 and 2 pi, and yet you wouldn't have mentioned it if you had just said pi over 6 and pi over 6. Oh, excuse me, pi over 12 plus 1/2, and 5 pi over 12 plus 1/2. That angle is not one of those, and yet it's on in the interval 0 to 2 pi and solves this equation. So that's the issue. We get like twice as many solutions as we normally expect on a given interval. Okay, one more for you to work on while I pass some things out. If you get this, let me know. There's a special prize. Yeah, if you get it first. Yeah.
Oh, never mind.
Usually, yeah. To get the prize, yeah. I'm out. Hey guys, I'm gonna pass out the speed trick quizzes. If you have an answer that you think is right, but it was marked wrong, I think it's possibly because I had someone grade this, and they didn't accept equivalent. They didn't accept ration. I mean, sometimes if it was rationalized, they didn't accept other forms of the answer. So just be aware of that. Okay, so if you think you have the right answer and it's just like a different form of the answer, then just put it up in a pile on my desk. Okay. Anyone have this answer yet? You might get it like that. That's true for you. Anybody get the solution? Yeah, I'll what you say you get. Jasper. Check through it properly and also make sure you see what the question asks. But that's not the only issue.
If I get a 9 on the last one, if I get a 9 on the last one, I would be so mad.
And then it says for all.
Every time I crack
Anybody get it? We're in.
when I turn,
I think I got it this time.
Despite this, everything goes to 2.3 miles. There you go.
It's the same, just put it in a pile for you. I got 36 on Hey guys, let me say it one more time because I think people weren't listening. If you think you have an equivalent answer on the speed trait quiz, put it up there and I'll regrade it. I'll give you a point back, okay? I thought I said that already. Maybe you missed that memo. Sorry about that. I will make the right, the wrong right. Did you get it?
I don't know what to do, because like after I subtract no, it's not.
Alright, you gonna start with it? Which one?
Put this problem up there. Can someone who got the right answer on this, put this up? Who's putting this up?
Well, you got
What do you want?
It should not be brown. I don't know why that's orange. Okay, I guess these ran for no reason. And actually, this is literally the only thing that
And then I got an email.
yeah, that was actually
Alright, Shane, you want to Alright, I need your attention for the last 60 seconds, please. Sit down unless your name is Cheyenne or Keisha. Sit down, Jeffrey, okay, thanks, Oren, Angela. Okay, let's, now I don't have a lot of time to say anything about the text. I think I've made clear what errors you made, so if there is any further questions, you know, today's short. I would have liked to have a little more time to go over it. Absolutely, please, just as a standing rule, you may come in any time at all to like peruse your test at your leisure. They just can't leave the room at all. So feel free to come at lunch or after school and just like spend hours looking at them, studying what you did wrong. That's fine. We can discuss them. And, but generally, in general, people did well, right? Lots of good scores. So good job in general. There are two things coming to you right now. So when you're done looking at your test, just put it in your folder and stack all the folders in one place on your table as usual. Thanks for listening, guys. Uh-oh. Okay. Thanks, Listen, guys, there are two things that just came to you. One is the homework for tonight, which says prove or disprove on it or whatever. That one sheeter, front and back. That's your homework tonight. That says homework 5 on your homework sheet. Says supplemental worksheet. That's that worksheet. The other, the challenge problems are for you to like start working on whenever you like. There will come a time when like, I'll hold you accountable for some of those, but that time has not yet come. We'll like spend some time in class on them eventually. Okay. If one person from your table would bring up all the folders to the front, that would be great. And put them in a stack. Thank you. The only homework is the prove or disprove worksheet, okay? You don't need to do any of the challenge problems yet. Okay? If you need some more problems in your life, though, you can do that. Short by one. Is that next step? Wonderful. There we go. Oh yeah. Okay, so they got to use the same letter. So just put me into the system. Yeah, but then you email if you find something or where to send the letter or something. Or they'll email you. I'd love it.
I got a 44 of this. Oh, finally.
Nice out.
Hey,
Yeah.
I got a 49 this one, 65, and then 90 on GLS. So, and I went to sleep at 12, okay, so I'll be
Oh, this is one I need to look at.
Possibly.
I don't care. I don't need it.
Guess what?